Think about the last time you organized your desktop. You click a single file, ask for its properties, and see its size. You click a folder containing thousands of nested files, ask for its properties, and it does the exact same thing. You expect this behavior. But under the hood, treating a single item and a massive cluster identically takes a specific kind of architectural logic. This invisible alignment, where the system ignores whether it's talking to one object or a group of objects, is a formalized software architecture. This is known as the Composite Design Pattern. Foundational structures that eliminate the distinction between a part and the whole allow for scale without the need for manual, complex logic checks. Hard-coding separate logic for individual items versus collections quickly violates the open-closed principle. Every time requirements change or a new type of item is introduced, you are forced to modify existing working code. That creates a fragile system that is difficult to test and maintain. The composite pattern solves this starting at the top, the component interface. This interface establishes a shared boundary, a strict contract that both single objects and groups must rely on. Below that boundary, the roles are strictly defined. On one side, the leaf represents the simple, interchangeable base units. On the other, the composite acts as a recursive wrapper that loops back to the top-level interface. This hierarchy isolates the outside world. The calling system only communicates with the top-level interface, entirely bypassing the concrete implementations of the leaves or the composites living below. Isolating the stable abstraction from the variable implementations is the mechanism that shields the main application from the chaos of recursive data. Let's map this diagram to physical objects to see the correlation. A single paper document acts as the leaf. A physical folder acts as the composite. It doesn't have inherent content. Instead, it's a wrapper forwarding actions to nested items. Once you internalize this direct translation between real-world taxonomy and code structure, the perceived complexity of the pattern disappears. To build this, we define the file system interface and its show method. We construct the file and folder classes to meet that contract. Notice the folder maintains an internal list of file system references. Inside, it loops through its children and tells them to execute. When assembled, the client can deeply nest items. Because of the recursive setup, executing one command cascades down through every nested layer. Since the client only touches the shared abstraction, engineers can slot entirely new variants into the system later with zero downstream changes to the caller. Observe the fully assembled architecture. Notice the strict upward dependency directions holding the pattern together. Every concrete piece relies only on the interface above. This discipline ensures that the work you do today prevents the need for extensive modification when the system evolves tomorrow. Like any architecture, the composite pattern introduces structural indirection and moving parts. That complexity must be justified by the requirements of the project. The benefit is the uniform treatment of elements, but the drawback is the loss of strict type safety. It becomes difficult to restrict exactly what can be placed inside a composite structure once they all share the same interface. Use this pattern when you see specific signals, rendering UI component trees, navigating file systems, or managing deeply recursive data structures. In technical interviews, avoid the common trap of confusing composite with the decorator pattern. The difference is the goal. Decorator is used to add behavior to an object dynamically. Composite is used strictly to build a unified tree structure. At its core, composite is one idea, creating a tree structure where the client treats an individual object and a group exactly the same way. Mastering these structural patterns shifts your perspective from reacting to disjointed code to intentionally architecting resilient systems.